We present EStatiG, wearable haptic feedback with multi-phalanx electrostatic brake for enhanced object perception in VR. EStatiG is a haptic glove that can deliver force feedback to all finger regions, from the fingertip to the proximal phalanx, to enrich the perception of the various object shapes during the grasping tasks in VR. As each object has unique geometric features, such as curvature and angles. By incorporating additional force feedback, we can effectively distinguish and replicate these features, increasing the realism of the virtual objects. We designed and fabricated the mechanical structure to accommodate the force feedback rendering that can cover all phalanges, while maintaining the thin and light structure with the weight of 130 grams. To block phalanx movement, we 3D print phalanx lockers and wrap them with fabric around each phalanx to provide comfort when bending and extending the finger, and added force conveyors on the palmar side to increase force sensation. We also use LIA motors on the dorsal side of the distal phalanx to provide tactile sensation. Lastly, force sensors are installed on the fingertips to detect the user's grasping force. Inside the actuator holder, we make the electrostatic brake modules consist of top and bottom strip, which are aluminum electrode, and the sliding strip, which is made up of conductive and dielectric layer. The strips are stacked and form a total braking area of 10 square centimeter. The brake can be operated by applying a potential difference across the strips. When no voltage is applied, the strip can slide and the phalanges can move freely. But when voltage is applied, they become fixed as the top and bottom strips are attached to the sliding strip by electrostatic force. This creates a blocking force and resists movement. Electrostatic brake modules are housed in actuator holders. Each module operates independently to stop the movement of each phalanx. To evaluate the performance of our device, we measure the maximum blocking force at different voltage levels. The results show that the friction force increases proportionally to the increase in voltage. We also determine how much force is actually transferred to each phalanx with our prototype. By measuring the normal forces acting on the phalanx against the anchoring force on the wrist. With the increase in wrist anchoring force, we saw a high increase in force transfer rates of over 90% on average at 5 Newton. This is how our electrostatic brake module operates at 350 volts with 10 Hz bipolar square wave. With multi-phalanx force feedback, user can perceive a distinct sensation when grasping different shapes of objects. As a result, our haptic gloves can be used in a variety of applications, including industrial training, teleoperation, entertainment, and third-person.